Alright guys, last video of activity 4. What we're looking at here is I'm going to give you kind of the answers for 12 through 16 on page 48. As far as how to work them, I'm not going to give you these answers exactly. And then we're going to look at the homework. The homework itself, the assignment is on page 49 and 50. We're doing 6 through 9. We're doing 17 through 19. And we're doing 26 and 27. And you'll see these numbers listed on your calendar that has all your activities and your homework for each day, okay? So again, those questions are on page 49 and 50. So let's look at the questions you just did. Let's look at 12 through 13. What I've done is I've given you the magic. I'm not going to give you the answer, I'm giving you the magic. I'm giving you what it looks like algebraically, the setup of these. So in number 12, they tell us D is on the interior. Because D is on the interior, we know this relationship to be true. We know that this part of the angle plus this part of the angle has to equal the whole thing. So here's your setup. I'm not going to solve it for you because I think you're better than that. Here's the next one. You notice on 13 they say QS bisects PQR. So PQS is 5x and RQS is 2x plus 6. It's giving us the two parts. Remember with bisect, the parts are equal to each other. So we simply say 5x is equal to 2x plus 6. Then you're going to solve for x and plug it back in to find out what they're asking for. Number 14, definition of complementary means they add to 90 degrees. So that's the magic in 14. One part plus the other part equals 90 degrees. You're going to combine like terms, you're going to do some algebra, and you're going to solve for the x, okay? And then plug it back in if you need to. Number 15 is an interesting problem. I really like 15. 15 actually has the diagram off to the side, so make sure you use that diagram. It'll help you to see it. But it says that EA is perpendicular to ED. Wait, where does it say perpendicular? Right there. You see that symbol? This symbol right here. This means perpendicular, okay? This means parallel. If you have two lines next to each other, that means parallel, which means they do not intersect if they're in the same plane. Perpendicular means they intersect within 90 degrees, and that's where the magic comes in because it gives us equal to 90. And we need that equal sign. Keep in mind the fundamental theorem of algebra says the only way to solve for a missing variable is you have to have an equation, okay? In fact, you have to have the exact same number of equations as you have variables. And for us today, for most of what we're going to do in this course, we're going to have one variable. But in order to solve for that variable, it means we have to have an equation, okay? So that allows us to set up our equation in 15 where it's equal to 90. So notice what they do. They say that EB bisects AEC, okay, and that's kind of weird. You look at the diagram, and really what they're saying is that the top two angles there are going to be equal to each other. So if we draw this, I'm going to do a rough sketch here. Here's my 90 degrees, and then I have one angle here, and then I kind of have a bisector, meaning that this angle has to match this angle, okay? These two angles are going to be equal to each other. Now let's look at what we have. They tell us that this one is 4x plus 1. They tell us that this one is 3x. All right. Now, how much is the missing angle? And that's what they're asking for, is the missing angle. Well, notice these two are equal to each other, so we can simply copy that expression. So that expression was 4x plus 1, so I'm going to put 4x plus 1 here. And notice what happens. All of a sudden, I have a full equation that I can solve. I can do 4x plus 1 plus 4x plus 1 plus 3x equals 90. That would allow me to solve for x. And once I've solved for x, I can turn around and plug it back in to find the missing angle. So that's how 15 is going to work. Again, I really like 15. I think it's a good problem. 16. 16, you're going to get introduced to a new concept. In mathematics, we talk about whether or not things are true or false. And really what we do, instead of proving that things are true, we try to prove that they're false. And the way we do that is we use counterexamples. A counterexample is something that doesn't fit the definition, okay? So, for example, if you were saying everybody's with the first name of Jose has the last name of Garcia, but you could find somebody with the first name of Jose whose last name wasn't Garcia, that would be your counterexample, okay? Jose Mendoza, whatever, that would be a counterexample. For us, we're looking at mathematics. Here we have the counterexample. It says that W is on the interior of X, Y, Z. And what she tries to say in the problem is she says, oh, those have to be equal to each other. I say that's not true. I say that W doesn't necessarily have to be the bisector. And notice in my picture, this angle is much smaller than this angle. Therefore, the measure of X, Y, Z does not equal the measure of angle, X, Y, W does not equal the measure of angle W, Y, Z. Okay, and that's my counterexample, and that's why she's false. So, guys, good job on activity 4. I want you to go ahead and break. You're going to be probably moving on to activity 5 now. If your day is over or if you have time, the homework that you're going to look at is on page 49 and 50. We're going to do 6 through 9, 17 through 19, and 26 and 27. That does not mean you can't do all of them. They're all good questions. But these are the questions that we feel would be the most beneficial to you. All right, good job, guys. See you tomorrow.